Hi guys, this is a video about how to make a graph using graph paper. Okay, so what we got here is some data that has been taken over our terminal velocity prac. So we can see in the far left column here, we got the distance, which is given in centimeters. We've got a couple of trials that we've taken for a particular time of an object falling. We got the average of that, and we got the average speed. Now, a lot of us find it quite confronting when we're just presented with some graph paper like so, and we're expected to graph these results. But if we break this data down into pieces that we can manage, everything should fall in place, and we should do minimal thinking. So let's see if we can fix this up and make it a bit easier for us to deal with. Okay, so the first thing is to kind of work out what data you're going to be using for this. Now, we're doing a velocity versus time graph, so we've got to be conscious about what's going to go in the horizontal axis and what's going to go in the vertical axis. So we'll start doing some writing up here. So let's have a look. So, and the horizontal axis, we also call that the x-axis. This is going to be our independent variable. It's the one that we change. Okay, and in this instant, it's going to be time. As time changes, the speed is going to have an impact on it. Now let's look at our data set. We can see that our lowest value is 0.42 and our highest value is 1.25 seconds. 1.25 seconds. Okay, now this is quite interesting because we need to figure out to create a graph, what is the highest number that we can take all these data points to. It's nice to choose a number, a whole number. So 1.25 is not going to cut it. So 1.3 is probably something that we can do. So the highest number is going to be equal to 1.30. Okay, that's good. So let's move on up. Let's see if we can break this down a bit further. The thing that people have struggled with is coming up with a way to create a graph that includes all these data points and fits them fine. So say we know that we're going to start here at 0, and we're going to travel down this line to some point over these increments and get to the final point of 1.3. We've got to figure out if we're going to go up by intervals of 10 or intervals of 5, and we've got to use that knowledge to figure out how many of these divisions or intervals we're going to put in place to fit all this data on, and that's what we'll do now. The first thing to figure out is what your interval is going to be. Now, interval is an interesting thing. Your interval is by how much you're going to be increasing each one of these values. So you can choose to go up by 10 squares or by 5 squares. And you've got to choose how much would the whole value would be. Usually is some rounded number, some rounded whole number. Okay, here we can see we're going to go up to 1.3, so we need some kind of decimal. So we'll try an interval of 0.1. Okay, so what that's saying is from the 0 point to this point here, it's going to be equal to 0.1, and I'm going to go up by those intervals. So that's going to be 0.1, that's going to be 0.2. Okay, now let's see how we can figure out how many intervals I'm going to need in total. Before we do that, let's have a look at how much is each one of these increments going to be worth. So we call them increments. So the way you do this, the increments is equal to the interval divided by the number of squares. Okay, so that's 0.1 divided by 5 squares. It's going to tell me that each one of those intervals is going to be equal to 0.02 seconds. Okay, so let's have a look at how many intervals I'm going to need. Okay, so the total intervals I'm going to need is equal to the highest number divided by the interval. So that is 1.30 divided by 0.1, that gives me 13. I need 13 intervals. So let's have a look. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's going to be 0.1, 0.2, 0.9, I get 1 second, 1.1, 1.2, 1.3, and that's the highest number I'm going to get. So I got my x-axis done. I've got to figure out what I'm doing with my y-axis now. Now there's a little bit of a problem, because if you look at the data, this data, I start with a really high value of 120, and my next high value is about 160. So I've got to figure out how I'm going to do that. Now I can apply the same principles that I've done here, and I'll do it so you can see what's the problem and how you can fix it in order to make it work for you when you're plotting your graph. Okay, our y-axis. So this is our vertical axis. We also know it as the y-axis. This is where we put our dependent variable in. And it just happens to be that it's average speed. We are referring to it as velocity. Okay, and we can see the data spans from 120 centimeters per second to 159.57 seconds. So we can see that our highest number is going to be something close to that. So we're just going to round it up to the next 10. You don't want to round down, you want to round upwards to the next 10. So we got 160 meters per second. It's going to be, we're going to round it up to our highest number. We're going to find out an interval. Okay. So we've got to choose how much the interval is going to be worth. So you can choose a couple of options. You can go up by 10 and designate that by 10. Or if you're dealing with a huge number like so, you might want to go up by 5, designate that at 10. So each one of those would have a particular value, which is 2, and we'll show you how we do that in a second. So let's keep on going with this process. So our interval is going to be, we're going to go with, it's going to be 10. It's going to be a value of 10 from the 0 point to the next mark between the five squares, then we're going to find our increment. Our increment is equal to 10 divided by 5 squares, and that's going to give me a value of 2. Okay, now we've got to figure out how many intervals I want to have. How many intervals do I have to go up along the y-axis to make this interval, the value of this interval and the value of each one of these squares being an increment of 2 work. So let's have a look. Remember, so the total number of intervals is equal to the largest number, which is 160, divided by the interval, which is 10. Okay, you can see that's going to give me a value of 16. That means I have to do I have to go 16 intervals. I don't think I have it available to me. Look. 1, 2, 3, 4, 5, 6, 7, 8, 9. I do not have that amount of space. So I'm going to have to modify this. Whether we can create a modified interval here, is by choosing the lowest number and making that the place where it starts. So rather than starting at 0, we'll start at 120. And we can do this in science as long as we indicate that. In mathematics, you've got to show the entire scale. So let's have a look at how we do our modified interval. Okay. So the first thing that we want to do, we want to figure out how much is there between 120 and 160, right? So once we do that, which happens to be 40 units that are going to span. So that's right. So we got a number. Now this is going to be our artificial interval, and we're going to use that to create a scale to make this vertical axis work. So let's work on that. Okay. So now we know that our highest number is equal to 40. That's great. We will choose an interval equal to 10. So that means in this particular instant we're going to say every 5 squares is equal to 10. We're going to find out that our increment is going to be the same, which is a value of 10 is going to be divided over 5 little blocks, and that's going to give us an increment of 2 in each one of the intervals. And now we figure out the total number, total intervals is equal to 40 divided by 10. We find out that there's 4 in total. So let's do that. So that looks like this. So here, that's going to be equal to 120. It's going to be equal to 130. It's going to be equal to 140. It's going to be equal to 150. And that's going to be equal to 160. Right? Okay. Now just remember, each one of these increments is equal to a value of 10, and each one of these blocks is equal to 2, right? So now we can start plotting our data. Okay, so we don't really need this data, we just need this. So let's use that. Okay, so at 0.42, the value is 120 centimeters per second. So at 0.4, we know that we're going in increments of 0.02, so that means 0.4, 0.42, that's where we're going to do that dot point. It's going to be at 120, the y-axis is at 120, so that's our first dot point. Excellent. Let's move to our next ones. So at 0.58, so we got 0.5, 0.52, 0.54, 6, 8. It's 129.31. Okay, so we know just before 30, and these are increments of 2. So we got 122, 124, 126, 128, 129 is about in between. Now you can't get this perfect, but you approximate whatever you can. So 129 is pretty accurate considering the scale. I mean, you could probably broaden this up if you had a bigger paper and stretch that out and have those intervals different, larger, much larger, and each increment worth less. So then you can accommodate for all that. But I think with this exercise, this is fine. So let's speed through these plots. Okay, so we're up to 0.97, so we got 0.9, 0.92, 94, 96, 98, 97 is in between 96 and 98. That's fine. Now we got 154.11. So we'll go up here. So we're up to 140. We got 150, and we got to go up to 157. So that's 52, 54, 56, 57. Okay, then we have okay, so here we have 0.97, so 92, 94, 96, 98, 97 is in between, and we've got to go to 154.11, so we know that's 140, that's 150, 152, 154, that's probably the closest number that we're going to get. And now we go on to the next one at 1.11, so we got 1.12, that's not much too much, so it's around here, 1.11, and that's at 157.19. Okay, again, so we go all the way up to 150, 52, 54, 56, 58, 57, and our last one is at 1.25, so 1.22, 1.24, 1.26, 25, and that's at 159.57. So we got 150, 52, 54, 56, 58, and 59. Okay, probably closer to the 160, but that's fine. Now what we do is we come along with our ruler and rule our line in. So because it's a line graph, we're just connecting all the x's together. It's recommended that you use x's because it makes it a bit accurate to draw your lines. A lot of people do dots, and that's okay, but in order for you to get used to what you're going to be expected to be doing in your HSC, start using your x's. Okay, and the last one is there. Excellent. And that's the curve that we were, sorry, that's the line graph that we were after for our data on our terminal velocity.